Hi again. Now in this lecture we're going to see the coils or inductors. Okay? So coils or inductor. Okay? So the symbol for inductor is this. Okay? Or like this. Okay? This is inductor. This is the symbol for the inductor. And always the letter that means inductor is L. You will find always L in motherboards. Okay? So this is inductor. And for the transformer, you should differentiate between the transformer and the inductor. So the transformer contains one inductor or more. So if we draw this, as you see, so this is transformer, as you see, with two inductors. You can find also other transformer with more than two inductors. For example, you can find this. Okay, this is a metal. We will see in the next lectures the transformer. Okay, so this is a transformer with three inductors. You can even find transformer in this shape, as you see. Okay, this is another transformer, okay, with five inductors. Anyway, in this lecture we're going to see the inductors. Okay, so the inductor is always used with the capacitor in order to filter a signal. So the purpose of the inductor is the filtering of signals, especially for the voltage. Okay, voltage. For example, you can find in many schematics or circuit diagram or even motherboard exactly this part of circuit. For example, this is a chemical capacitor. We have here two chemical capacitor, for example, okay, related to the ground. Okay, you can find even here a diode, okay, to the ground. Okay, so this is chemical capacitor, and you will find here a coil, and then here we have our VCC, for example. Okay, so this is chemical, this is diode, and this is coil. Okay, so the coil, I will show you some coils, real coils, as you see. This is a coil, okay, in this shape. We have here another coil, okay, as you see. This is coil, and this is another, but this is a bad coil. Okay, this is another, as you see. We have two terminals here, means this is one coil and this is the second coil. Okay, we have two terminals and two terminals. We will use the multimeter, and I will show you how to check if this coil is bad or not. Okay, so we have here another type of coil, as you see. So we have here two colors. So this is the terminals for the first color, and this is the second, as you see here. Okay, so I have here a transformer. This is a small transformer. Basically it's not a transformer, but this is an EMI, or electromagnetic interference. Okay, this is used in the flyback power, okay, in the power electronic. Okay, we will see all this. So this contains two inductor. This is the first, as you see here, this is the first inductor, and this is the second. For this inductor, it has two terminals, as you see, and this other has two terminals. So to check this, okay, to check these coils, we should use the multimeter, and also we should check using these terminals. So for the coil, we can check it using the same principle like a fuse. Okay, we should put the multimeter in the buzzer option or the continuity option, and then use the probes of the multimeter. Put one probe here and the other here. If we hear a buzzer, means the coil is good. If we don't hear any buzzer and we don't see any reading in the multimeter, that means the coil is bad, means it is cutted, exactly like this, as you see. Do you see this? This means this coil is cut, is cutted, as you see. This is a bad coil. Okay, so let's use the multimeter and check our coils. So the same working principle here. We have one terminal and this is the second terminal. So we should put one probe of the multimeter here and the other probe here, and we should get 0, 0, 0 ohms in the multimeter, or 0, 0, 1 or 0, 0, 2, no problem. Okay, so let's check these coils. Let's check this first. As you see, so we have the first, we have second, so this is two terminals. Okay, so I should first choose the buzzer option, always as you see, and press the power button. Okay, when in the multimeter mean open or overload. When means open, no continuity. Okay, now if we connect this two probe, as you see, we have 0, 0, 1 means 0, 0 means a continuity, a buzzer. Okay, so let's check this. So let's put it here. So I will put one probe here in this terminal and put the other probe here, and let's see right now the multimeter. Now we have 0, 0, 1 means this coil is good. Okay, let's check the other coil, also good. As you see, we hear a buzzer, and as you see here we have 0, 0, 1 means 0 ohm, means this is good. This is good, exactly like the fuse. Okay, so let's check this also. So we should put one probe here in this terminal, as you see, like this, and put another here. This also is good. Let's check this also. Also good. Okay, this is good coils. So let's check this. So when you find coils like this, as you see, with the color here, this is, we have here rubber. This is not an inductor here. Okay, here this is a rubber. So if I put the multimeter here in this part, for example, if I put the multimeter here and put the other probe here, as you see, we don't hear anything because this is a rubber. This color is a rubber. Okay, no conductivity here. We should put the multimeter here. Okay, so we should put the probe here in this terminal, as here and here, as you see. Okay, but here, no, here. Okay, the same also for this coil. Should put it here in the edge. So it's good. This is also good. Okay, these coils are good. Now we will talk about how to replace a coil, a failed coil. So all these coils are good, but let's assume that, for example, we find that this coil, for example, is cutted, is not good. How can we change this coil? Simple. We should replace it with another same coil. For example, For example, this, we can replace it using this. Okay, even if this is, we don't have here terminals, this is a bad coil. Okay, so for example, if we find that this coil is bad, we can replace it with another coil that is good, but with the same shape and same number of this rotation. Okay, same. Okay, we should confirm that this coil, the bad coil, has the same characteristics as the good coil. Okay,